So we're finally moving on to Chapter 5. On this section 5.1, we're going to learn how to simplify monomials using rules of exponents. Rules of exponents, there's 7 rules of exponents, or 6, depends how you look at it. And we're supposed to have already mastered that in Algebra 1. In Algebra 1, we take a good week and a half, sometimes 2 weeks on these 7 rules of exponents. Right now we are taking about 30 minutes tops, right? We should already know it. And in addition to that, we're also going to know how to subtract, add, multiply polynomials. But then again, we've been doing that the whole time. So whenever I say to distribute this, that's already multiplying 2 polynomials. Technically a binomial times a binomial. Okay. So we've added polynomials, we've subtracted polynomials, we've multiplied polynomials. So that's just a review. So pretty much this whole lesson is a giant review of things that we've already done. Let's move on to the actual 7 rules of exponents. Rule 1. Okay, now this is the most important rule. If you are multiplying 2 terms with the same base, then you simply add the exponents and keep the base. So right here we have an example, x to the second times x to the third. Yes, we're multiplying, but what happens with those exponents? You simply add them together, it becomes x to the fifth, right? Why is that if we're multiplying, right? Shouldn't we be multiplying 2 times 3 and getting 6? No, the thing is this, x squared is really a x times x, right? And x to the third is really a x times x times x. And we are multiplying them together, so it's really just 5 x's that are being multiplied together. So that's exactly why rule 1 is when you're multiplying 2 terms with the same base, you get to add the exponents. So keep in mind, it doesn't work. If you have like x to the second times y to the third, you can't add those together because they're not the same base, right? Okay, so you guys right now, you don't have to copy this down exactly. Maybe you want to just write down rule 1 and just write down this first example, x to the second times x to the third, you get x to the fifth, right? Let's take a look at more examples. Now you don't have to copy these down, right? You can just sit back and watch. So if I do have 2x to the fourth times 3x to the second, these are coefficients. They're numbers that are out in front of the variable. And in reality, it's just multiplication. It's really saying 2 times x to the fourth, and then times 3, and then times x to the second. So there's this thing in multiplication called commutative property, which means you could rearrange things. So I would put the 2 times 3 first, and then the x to the fourth times x to the second second. And of course, 2 times 3 is 6. Whoops, what happened there? That's weird. 2 times 3 is 6. And x to the fourth times x to the second, that's where we add them, and we'll get 6 as well. So again, we are adding exponents. Again, this is from Algebra 1. I hope everybody understands it. Let's try one together here. Let me delete this. How about you guys try number 2 right here? Go for it. I'm going to pause it, then I'm going to ask somebody to answer it for me. Okay, that is correct. The answer is 30x to the 11th. Once again, multiply the coefficient with the coefficient. 6 times 5, that's 30. And of course, the x to the 5th times x to the 6th. Simply add the exponents, and you'll get x to the 11th. Let's try one more, then we'll be done with this rule. This one looks complicated, but it's not, right? Let me make some more space for it here. This is definitely not complicated. It looks complicated, but it's not. Why? Because it really is all pure multiplication. You have 3 times x squared times y to the third times z times 2 times x times z. So we could just rearrange this thing, right? What's your coefficient going to be on your answer? 6. All right, so let's write down 6. And of course, in math, you always want everything organized. So let's put these 3 different letters in alphabetical order. We're going to begin with the x's. So if I did x to the second times x to the fifth, what would I get? X to the 7th, perfect. Okay, and how about y to the third times, there is no other y, so just bring that down. And last but not least, what if we have a z times z to the 7th? Z to the 8th. Perfect. We are done. This is our answer. So that is rule 1 of exponents. It's the most important rule. It's very basic. Let's move on to rule 2. Rule 2, and again, you don't have to copy down the description itself. If you want to, go for it. But I do want you to understand, or at least copy down this basic example. When you have a power to a power, that's when you multiply exponents, right? Power to a power, that's when you multiply exponents. So if you're thinking, why am I multiplying? Shouldn't it be 2 to the third power? No, the thing is this. When you have a power to a power, you multiply. Why? Because this base is x to the second. And we're going to do to the third power of this base x to the second. So this power of 3 tells us that we're going to rewrite this 3 times. Now, you don't have to show this work, all right? But again, the power of 3 is telling us that we're going to have to rewrite this 3 times. So x squared times x squared times x squared. And based on rule 1, when you have the same base, you simply add 2 plus 2 is 4 plus 2 is a total of 6. So that's why your answer is x to the 6th. Everybody with me? You don't have to show this work. Heck no, it's actually a waste of time. And that's where these rules come from, guys. Mathematicians they don't magically create rules. They observe and they come up with shortcuts. So the shortcut is this. Whenever you have a power to a power, simply multiply them. Okay? How about this guy right here? What's the answer to this one? X to the 56. That's right. Piece of cake. Too easy. How about this guy right here? 2 to the 6th. That's right. Now, whenever you do have a coefficient, all right, whenever you do have a coefficient or a number to a certain power, it's not good to just leave it like that. I want you to actually work it out. So what would 2 times 2, that'd be 4 times 2, that's 8, times 2 is 16, times 2 is 32, times 2 is 64, right? So the answer there is 64. Final answer, that is. Moving on. Power to a power to a power. It's just all multiplication. What's the final answer going to be? X to the 30th. 5 times 3 is 15, times 2 is 30. Boom. Easy peasy lemon squeezy. That's rule 2. Let's move on to rule 3. Actually, rule 3 and 4, you could lump them up together. That's why I said at the beginning of that you could consider it 6 rules instead of 7. Rules 3 and 4, by the way, you don't have to memorize, oh, rule 1 was this, rule 2 was that. As long as you know the truth and what to apply when, you're good. So rule 3 and 4, if you have parentheses with an exponent on the outside of the parentheses and pure multiplication or division on the inside of the parentheses, then you distribute your outside exponent to each inside exponent. I probably should have said exponent. So each outside exponent, you're going to distribute it to the inside exponent. And remember rule 2, power to a power, multiply. So as we see right here on this example, we have parentheses here with the power of 3 out here. We're going to take that power of 3 and put it on each exponent. Now remember, power to a power, you multiply. So what power is on the 2 right here right now? There's a 1. So when I put the 3 right there on the 1, it's really saying 3 times 1. And 3 times 1 is what? 3. So you really have 2 to the 3rd, right? And then you have 3 times 2, that's going to be x to the 6th. There's x to the 6th. 3 times 1 is going to be y to the 3rd. 3 times 5 is 15. So all you're doing is taking that outside exponent and distributing it, putting it here, putting it there, and right there. You distribute it to each term's power. Likewise, if you have a parenthesis with an exponent on the outside, you're going to do the same exact thing. You're going to take that 2, put it right there on the 3, put it right there on the 4, which means you have to multiply exponents, put it down here on the 3, which means you have to multiply exponents, and you will get this final answer. Okay? And this is also very important to note. You cannot distribute exponent in if you have addition or subtraction. Okay, if you had something like x plus 3 squared, you cannot put that 2 on the x and then put that 2 on the 3. The answer is not x squared 9. That would be totally incorrect. So you cannot do that. Why not? Because there's addition. If there's addition or subtraction, you cannot distribute that outside exponent. So right here, look, there's no addition, no subtraction. Down here, no addition, no subtraction. If I'd have a plus in front of the x, between the 3 and the x, I would not be able to distribute. If I have a plus right here between the x and the 3, I'm not able to distribute. I have to do it a different way, which would be to rewrite it 2 times. Now we've done that we've done this in the past, where you'd have to distribute and then combine like terms. But anyways, that's for later on in today's lesson. Do we understand how to distribute the outside exponent in? Yes? Let's practice. What's the answer there going to be? See, a lot of people would say that the answer here is 2x to the 6th, and that's incorrect. It's not 2x to the 6th. What is it? 8x to the 6th, right? Again, are there parentheses? Yes, there are. Is there an exponent on the outside? Yes, there is. Is there any addition or subtraction in here? No. So that means I could distribute the outside exponent to the inside. So 3 goes on to the 2. It goes on to that power. So I really have 2. I really have 2 to the 3rd, x to the what? 6th. And 2 to the 3rd, that's really 2 times 2, which is 4 times 2, which is 8. Final answer, 8x to the 6th. What do you say? All right, cool. So again, you don't have to copy all these down. Just pay attention. What's the answer here going to be? Anybody?
8x to the 3rd, y to the 3rd, z to the 3rd.
8x to the 3rd, y to the 3rd, z to the 3rd. All you're doing is taking that power, distributing it to each and every term. Okay. That 2 to the 3rd becomes 8, not 6. Okay. Let's move on. Just one more before I move on to the next one. See right here we have parentheses. Again, there's no addition or subtraction on the inside. It's all pure multiplication and division. So we could take that exponent of 3 and distribute it to each and every term. So what am I going to have as an answer? It's still going to be a fraction. What do I have on top? X6, Z12, 8, Y 15. It's not that bad, huh? Okay, of course you have to memorize these rules. So that's rules 3 and 4 together. Only a couple left. Let's move on to rule 5. I love this one. It's a piece of cake. Rule 5. X to the 0 equals 1. What is the rule exactly? Anything to the 0 power equals 1. Okay? So if we have 5 to the 0 power, what's that? 1. If I have a z to the 0 power, what's that? 1. If I have happy face to the 0 power, what's that? 1. Easy peasy, right? Now, how about this one? 2 to the 0 power, what's that?
2 times 1.
Huh?
2 times 1.
Ah, I didn't trick you. That's good. The answer is what? 2. A lot of people say, oh, the answer is 1 because anything to the 0 power is 1. Yeah, that's true that anything to the 0 power is 1. But right here, you really have, let's look at the problem here. You really have 2 times x to the 0. The only thing that has a 0 power is x to the 0. The 2 does not have power of 0. So right here, your real problem is 2 times 1, which is 2. Okay, so don't just think, oh, whenever I see that 0, the answer is going to be 1. If you ever have something out in front, a coefficient out in front, the coefficient will technically be your answer, like on this one. But we do have all these examples. Yeah, what's the answer here? 1. Why? Because what's the rule? Anything to the 0 power equals 1. We have a bunch of stuff in here, but it's all in parentheses. All of this is to the 0 power. That means that the answer is 1, right? So the answer is 1 right there. Ooh, it's getting crazy. So what? It's all to the 0 power, so the answer is 1. No, not 23. The answer is just 1, right? Again, see, the explanation is this. If you take that 0 power, put it on the 23, it'll be 23 to the 0. It'll be x to the 0. It'll be y to the 0, 13 to the 0, which means you have 1 times 1 times 1 times 1, which is all 1, right? As long as the parentheses is covering a bunch of stuff and the zeros on the outside, yeah, the whole thing is going to be 1, okay? Even this nasty looking one right here, the answer is 1. Why? Because, yeah, you could start distributing 7, put it on the 3, but that's all pointless because a power to a power, you multiply, so that's really a 0 on the whole thing, so the answer is 1. So rule 5, I love it. It's easy. Anything to the 0 power is 1. Let's move on to rule 6. This one's interesting. Negative exponents. Whenever you have a negative exponent, you must move it to the other side. Now, what do I mean by that? From the numerator to the denominator or from the denominator to the numerator. But you do not want to leave a negative exponent, okay? So here's an example. Let me zoom in on it. Where is there a negative exponent? This guy's a negative exponent. I usually circle the term with the negative exponent and then draw an arrow to where I'm going to move it. So that's why this answer becomes y to the 5th alone up on top. And on the bottom, you have your x to the negative 3, which became x to the positive 3 on the bottom. So again, anything with a negative exponent must be moved to the other side from numerator to denominator or vice versa, and the exponent will become positive. Let's do a couple of these examples. What's the answer number 1 right here? Perfect. The only thing moving is what? The x to the negative 3. It's going to move down. The 2 is not going to move. The 2 does not have a negative exponent. So your answer will be the 2 stays up there, and the x to the negative 3 becomes x to the positive 3 on the bottom. There's your answer for that one. Okay. Let's try another one. What if the whole thing were in parentheses? Then the whole thing does move down. So what's your answer going to be? You're right, 1 over 2x to the 3rd, but is that your final answer, or could you do anything else? You could distribute. You got to use, see, the thing is, the beauty of this section is that you're going to learn all these rules, and you're going to be applying different rules on the same problem. So after moving it, okay, you could distribute that 3 to the 2 and to the x. So your final answer should be 1 on top, 8x to the 3rd on the bottom. Okay? Let's try another. What am I moving? Just the y, right? So I'm going to circle y to the negative 2, and I'm going to put an arrow moving it up. Final answer will be 2 with the y to the positive 2 up there over x. Get it? Got it? Good. All right, let's move on. Rule 7, last one. This is a canceling out rule, right? We already know that if you have something like 3 over 3, what's the answer there? 1. It's 1. This cancels out, right? So that's exactly where this rule comes from. If you ever have the same exact thing on top over the same exact thing on the bottom, you could cancel it out. So on this example that I give right here, we have x to the 3rd over x to the 5th. Now, what does x to the 3rd actually mean? It means x times x times x. What does x to the 5th actually mean? X times x times x times x times x, 5 times. And of course, the x over x cancels, x over x cancels, x over x cancels. There's nothing left up on top, so you'd put a 1 up there, and there's 2 x's left on the bottom, so it'd be 1 over x squared. Yay? Okay. Now, obviously, you don't have to do this work. Again, these rules are simply shortcuts that mathematicians observed, and now you're able to use just to answer it quickly. It's kind of like subtracting, but I like to call it canceling, right? Because that's what's really that's what is really happening. You're canceling terms out. Some students refer to it as subtracting. But let's think about this. I mean, even the fraction 2 over 8, we already know that that reduces down to what? 1/4. But if you think about it, the 8 down there is really a 4 times 2. Okay, let me rewrite it. 4 times 2. 8 is really 4 times 2. And what happens is that the 2's cancel and there's 1 left up on top. And that's why 2/8 reduces down to 1/4. Right? That's the real reason why 2/8 reduces down to 1/4. So let's start reducing here. 2/8, we said it reduces down to 1/4. Now, how many x's do I have on top? 3. How many do I have on the bottom? 2. How many cancel with how many? 2 cancel with 2. So all these 2 completely disappear with 2 of these, and there's 1 left. And there's 2 y's on top, 5 y's on the bottom. Both y's up on top cancel with 2 of these 5, and there's going to be 3 left. So this is a work I expect to see when you're doing these problems. Your final answer will be a fraction with a simple x up on top and a 4y to the 3rd left over on the bottom. Let's do one more example, then we'll be done. What could I cancel here? The 4 and the 12, what's left over? 1/3. There's a 3 left over on the bottom, so that's right. Nothing up on top, 3 on the bottom, so that's a 1 over 3. We already know that 4/12 reduces down to 1/3. How about x's? Where's there an x left over? on the bottom, right? One of these x's cancels out with one of these 2, so you have 1 left. And the y's, where's there a y left over? On top. So 1y cancels out with one of these, and there's 1y left up on top. So the final answer will be a fraction with a 1y, or you could just put y, over 3x. That's your final answer right there. So we will be working on this worksheet right here for the rest of the class. And it's simple exponent rules. So the first half is exponent rules. The second half is simplifying polynomials, either by adding, subtracting, or multiplying. Right? So these guys right here, like let's say number 2. That's just rule 1. What's my answer going to be on number 2? C to the 9th power. That's it. Easy peasy.
Are you going to pass this out to paper?
I will pass them out shortly. Right here on number 4, we actually have 2 different rules to apply. You can apply 2 different rules. So it doesn't matter if you, what are the 2 rules that we need to apply? 1 and 3. And you don't even have to say 1 and 3. You could say add exponents because they have the same base, or negative exponents must be moved down to the other side. So there's many roads to the same place. You could choose to move this down first, which means that then you'd have to combine these guys and then cancel, or you could just add across the top. Either way, you get the same answer. So like, let's say, I want to do this both different ways. Let's say you took this one and moved it down. What would you have left up on top? You'd have x to the 5th times x over x to the positive 4, which means that x to the 5th times x becomes x to the 6th over x to the 4th. And then you would cancel out 4 of these with 4 of those and have 2 left over. So your final answer is x squared. What do you think? That's applying actually 3 different rules on one problem. Is that the best way to do this? Heck no. What's the best way to do this? Let me show you. I would say just rule 1. What is rule 1? If you have the same base, just start adding the exponents, right? So what's 5 plus negative 4? 1. And then what's 1 plus this other 1? 2. So your final answer is x squared. Ta-da. Easy peasy. So I did that purposely to show you that there's many roads to the same place. Some are longer than others. But as long as you're applying one of the rules that we went over, you're good. I don't know. I think we can handle this. Down here, the second half of this worksheet is no longer exponents. It's all about adding, subtracting, multiplying polynomials. So subtracting polynomials, we've done this in the past. All you do is distribute that minus sign. You'll have a negative d with a minus 1. That 5d plus 5 comes down. And then you combine like terms. 5d with minus d, that is 4d. And then the plus 5 with the minus 1, that's plus 4. So that's your answer for number 12. Adding and subtracting is the easiest thing in the world. Adding is just combining like terms. You don't have to worry about distributing. Right here, we're just going to combine like terms. Right there, just combine like terms. So what do I mean by combining like terms? F squares with F squares, F's with F's, and numbers with numbers. And yeah, I apologize, you don't have the worksheet yet. But you will get it shortly. Anyway, adding, subtracting is cake. Multiplying is just as easy. But of course, we had to go over the rules of exponents to be able to know what to do with those exponents. So right here, x squared times 2x, that'll be 2x to the 3rd. X squared times 9, 9x squared. That's it. That's your answer. We've already multiplied binomials times binomials. This one technically is a binomial with the same binomial, but it's conjugate, right? Which means that the middle terms will cancel out when you do the math. Would you like to see that example, or should I just give you the worksheet and get you started? One more example, okay. Let's do one that doesn't cancel. Let's do number 20 here. So it's simple as this. 3y times 2y, that's 6y squared. 3y times negative 3, that's negative 9y. And 4 times 2y, that's positive 8y. 4 times negative 3, that's negative 12. Combine those middle terms, a negative 9y with a positive 8y, You owe $9, you have $8, you're still going to owe $1. Bring down everything else. 6y squared minus 12, you're done. So this is a pretty easy section, but it will be the first section on the quiz Friday before Thanksgiving break. Let's do it.